Building the UI was honestly my favorite part of this entire project. Not because it was easier, it wasn't, but because for the first time I could actually see what I was creating. You change a color, instant feedback. Adjust spacing, it updates right there. With the backend, you are writing code that returns JSON responses. But with UI, you are designing something visual, something you can interact with. And that made this part actually fun. So in this video, I'm walking through the entire iOS app. Every screen, how they all connect, the architecture, and the biggest challenges I hit building this. The app is built with SwiftUI, Apple's modern UI framework. What made SwiftUI great for this app? First thing was live preview. You see changes instantly in Xcode without rebuilding the entire app. Adjust a button color, it updates right there. Second is reactive updates. When data changes, the UI updates automatically, no manual refreshing. Third thing is less code, more concise than the older UIKit framework. So now let's talk about the app architecture. The app is built on MVVM architecture, which is model view view model. This is a common pattern for SwiftUI apps. It fits naturally with how SwiftUI works. Model means your data structures. View is what users see, and view model is the bridge that handles the logic. MVVM is the most widely adopted pattern for SwiftUI apps. Not because it's required, but because it fits naturally with how SwiftUI handles data and UI updates. So now let's talk about how this architecture actually works. User taps bedtime stories, view tells to view model. Then view model fetches from backend. View model then updates its data and view automatically rebuilds with new stories. This keeps code organized. Views stay simple and just display things, whereas view models handle the actual work. As the app grows, this structure prevents everything from becoming tangled chaos. The project is organized into folders like models, views, view models, utility. Every major screen has a view file and a view model file. Now let me walk you through the entire app. Every screen, how they work. The app didn't start like this. The initial home screen looked completely different, less polished, different layout. The welcome screen had a different design. The story pipeline started simple, just stories. Then I kept adding features one by one, like age ranges, story categories, difficulty levels, reading progress, and achievements. Each feature built on the last. Here are some screenshots from when I first started. You can see how the app has evolved. So this is the welcome screen. This is what users see first. App title is GiggleTales and there is a subtitle which says let's imagine together with a gradient background with animated stories and clouds and two buttons, let's begin and I have an account. There's also an animated fox mascot that springs up from the bottom when the screen loads. The star animation in the background was designed specifically for kids. You know, like subtle, playful, and not distracting. So before you can go any further in the app, whether you tap let's begin or I have an account button, a parental gate appears. A simple math question. This is a mandatory Apple requirement for kids apps. Then we have the login page. The login screen handles three authentication methods. First is email and password, second Google sign-in, and third is Apple sign-in. Apple actually requires this. If you offer any third-party login method like Google, you must also offer sign-in with Apple. It's in their App Store review guidelines. The screen has multiple states. Default state with empty fields, loading state while authenticating, then there is error state if login fails, and the last is success state that navigates to the main app. Behind the scenes, there is an authentication manager that communicates with the backend API, stores authentication tokens securely in iOS keychain, and then manages the app's logged in versus logged out state. Each authentication method works completely differently. Google gives you an ID token, whereas Apple gives you a different token format. The backend has to verify all of these and issue its own session token. But once it works, it's solid and users don't have to think about it. After login, if it's a new account, you go straight to creating your first profile. If you already have an account, you land on the home screen with the default profile loaded. If you have multiple child profiles, you can switch between them anytime from the Profile tab. Each child profile has name, age, 5 avatar icons, 7 profile color options, reading level, language which is English only for now, and narration on or off, which means whether story is read aloud automatically or not. When you have multiple profiles, you just tap a profile and the app switches to that child's context. Watch what happens when you switch profiles. The entire app theme updates instantly. This is managed by a theme manager, an observable object that the entire app watches. When the theme changes, every view that uses theme colors automatically rebuilds with the new colors. The profile color isn't just decoration, it helps parents distinguish between kids at a glance. Once you are in profile, the app uses a tab bar navigation with 4 main sections. First is Home tab with story categories and browsing. The next is Favorites with stories the child has saved. Then the third is Activities with interactive learning and games. And the last is Profile tab with reading progress, achievements, settings, and profile management. SwiftUI makes this straightforward with tab view. Each tab is its own independent navigation stack, so you can go deep into one section without affecting the others. The Home tab displays story categories in a grid layout. Each category has a colorful gradient background with AI-generated illustrations and a category label. The grid uses SwiftUI's lazy V grid. It effectively loads and arranges items. On iPhone, it displays 2 columns. On iPad, it automatically adapts to 3 or 4 columns based on the screen size. On the Home tab, there is a search icon at the top. Tap it and you get the full Discover Stories screen. You can search by title or description. It auto searches as you type. Or tap the filter icon to browse with filters like categories, age range, difficulty levels, then language, tags, and sort by. You can tap the X or the cross mark to remove any filter instantly. And if you don't want to use filters, then just tap Browse All Stories to see all the stories across all the categories. Now let's talk about story list. So when you tap a category, you navigate to the story list for that category. This screen fetches stories from the backend API for whichever category you selected. So when you open a category, the app shows cached stories instantly if you have visited before. Then it checks for new stories in the background. First time, it fetches everything fresh. At the top, there are 3 tabs: Beginner, Intermediate, and Advanced. You can also swipe left or right to switch between difficulty levels. Above the grid, it also shows a count like 1 of 4 completed, so you know at a glance how far through the level you are. Each story card displays thumbnail image, story title, and completion status. Green with completed badge if finished, and orange with percentage if left halfway through. There is also a hide completed toggle to filter out finished stories so kids can focus on new ones. This screen has 4 possible states that the view model manages. First is loading, which is fetching data from backend. Second is error, which is network request failed. Third is empty state, which is no stories exist in this category. And the last one is success, which is displaying the story list. You can pull down to refresh and force fetch the latest stories from the server. Tap a story card, you navigate to the story reader. This is the most critical screen where kids actually read the stories. Each story has a cover page, multiple scenes, and a moral at the end. Every scene has AI generated illustration, story text, audio, and swipe left or right to move between scenes navigation. The heart icon in the corner lets you favorite the story. It saves to your favorites tab. If you left a story halfway last time, it opens right where you stopped, not from the beginning. Every page turned saves your progress automatically. There are 2 reading modes. The play button reads the entire scene aloud continuously.
In the warm, sunny savannah lived a tiny elephant named Noor.
While it plays, it becomes a pause button. Stop anytime. Also, there is auto advanced narration implemented. So when the narration finishes a scene, the story automatically moves to the next page. Kids can just listen without touching the screen. The second button is a speech bubble icon, which is a word by word mode. Each tab reads the next word and highlights it in the text.
The warm, sunny savannah.
Kids can follow along at their own pace. When you finish the last scene, you see a completion screen showing the story's moral and a button to return to the story list. Behind the scenes, the app records this completion in the backend. Parents can see it in the profile tab later under reading progress. Now let's talk about the favorites tab. The favorites tab displays all stories the child has saved. Same card layout as a story list, thumbnail and title. This data is stored on the backend. So when you favorite a story, the app makes an API call to save it to your profile. When you open the favorites tab, it fetches all your saved stories. To unfavorite a story, just tap the X button on the card or tap the heart again. It removes it instantly. The next is Activities tab. The Activities tab is where kids can play interactive learning games. There are multiple game categories with different activities in each. So here we have is shape tracing game. This is one of my favorites. The game shows a shape like an octagon and kids trace it with their finger. As they trace, different colored segments light up showing their progress. The app tracks their finger movement and fills in the outline as they go. It's simple but effective for teaching shapes and developing fine motor skills. The next we have is Find the Objects, which is a hidden object game where kids tap to find items in illustrated scenes. Before the game could work, I had to go into every single scene and manually draw invisible borders around each object, defining the exact tap region. Now here we have is coloring and drawing, which has two modes. Tap to fill coloring pages, which has 11 pages like house, car, butterfly, pizza, bear, and so on, where you tap a region and it fills instantly using a flood fill algorithm. And the next is creative canvas, which is a black canvas where kids draw freely with different brush sizes and colors. So two completely different experiences under the same category. All assets like images used for coloring are compressed to keep the app size small. Then we have a smart word building. This game checks the child's age from their profile and pulls words from an age-matched corpus. A 3-year-old gets words like cat, dog, sun. A 6-year-old gets animal, school, butterfly, adventure. The corpus is built in, so I can keep adding to it as the app grows. Then we have math games like add and subtract and multiply and divide. Younger kids like ages 2 to 4 get smaller numbers, which sums up to 10, and older kids like 5 and 6 get harder problems up to 20. The game checks the profile age automatically every session. Then we have jigsaw puzzles. In this game, images split into pieces based on difficulty levels. Kids drag and drop to solve. Themes include animals like tiger, lion, dog, and objects like fire trucks and ice cream trucks. Large images caused serious lag, like dragging pieces was very slow, especially on bigger 4x4 grids. So I had to compress all puzzle assets significantly to make it smooth. I also added numbers on pieces to make it easier for younger kids. There are other games too, like letter recognition and memory match. Every game has a pause button. Tap it and a pause overlay covers the screen so kids can take a break without losing progress. And when a game is completed, a celebration screen with confetti and animation appears. So now let's talk about the audio I used for activities. I didn't like Apple's built-in TTS voice for the games. So all reward and encouragement audio like correct answers, diagram messages, questions are pre-generated using Gemini TTS in AI Studio. The Apple TTS is just a fallback. All activities work fully offline. No internet needed, no caching required. Everything is bundled with the app. And last tab we have is Profile tab. This is where everything about the child lives. At the top you see the active child's avatar, name and age. Below that is reading progress, where you can see overall completion broken down by status, completed, in progress and not started, and then broken down by level, how far they are in beginner, intermediate and advanced. Then we have is achievements. There are 9 badges total. Things like first story, story explorer, speed reader, beginner master and so on. You can see which ones are unlocked and which ones are still locked. They are displayed in 3x3 grid. Unlocked ones show in full color, locked ones are dimmed out. So when you unlock a new achievement, a celebration pop-up appears automatically on screen. Then we have is choose profile, where you can select and choose a child profile if you have multiple profiles. You can also add a new profile here. When adding a new profile, you see add profile details like child name, gender, age from 2 to 6, choose avatar from 5 avatar icons, profile theme color from 7 options, then preferences like reading level, page and narration on or off. After that is manage profiles, where you can edit existing child details or add a new profile. There are actually two color systems in the app, and there is a reason for that. Each child profile has a profile theme color with 7 options. This changes title colors and accents throughout the app. It's mainly a distinction color so parents can tell at a glance which child's profile is active. Then there is tint, which has 4 options like default, ocean, sunset, and lavender. This changes the app background color. I originally wanted tint themes to be much bigger, like ocean themes would bring an ocean word feel, buttons would change, everything would transform. But when I implemented it, the app lagged badly. So I kept it simple for now. Just the background color changes. Something I want to revisit in a future update. Next is font size, which includes 6 options from small all the way up to 3x for kids who need larger text. And at the bottom, there is logout and delete account options. All this data, progress, achievements, profiles is stored on the backend and syncs across devices. Now let me talk about some technical problems I ran into building this. Challenge 1 was real device performance. Everything worked perfectly smooth in the Xcode simulator, buttery animations, instant image loading, zero lag. Then I tested on an actual iPhone and suddenly images loaded noticeably slower. Animations stuttered and dropped frames. Scrolling felt janky and memory usage was way higher than expected. I had to fix 3 things. Cache images on the device so they never download twice. Second was only render what's visible on screen, not the entire list at once. And third thing was reduce unnecessary UI updates. Then challenge 2 was state management. The story list screen isn't just a list. It has multiple states it needs to handle. First is loading, which is fetching stories from the backend. Second is success, that is stories loaded, then show them. Third was error state, which is if network failed, show error message. Then fourth was empty state, which shows no stories in this category. So you have to manage all the states carefully. MVVM helped here. All of this logic lives in the view model. The view just watches and displays whatever state the view model is in. Challenge third was authentication flow complexity. So GiggleTales support 3 login methods: email password, Google sign-in, and Apple sign-in. Google returns one token format and Apple returns another. The backend has to verify all 3 and issue its own session tokens. Then there is a token storage. You can't store tokens in memory. They disappear when the app closes. iOS has a secure storage system called Keychain, but the API is old and verbose. Storing one token takes 15 plus lines of code. So I built a Keychain Manager, a utility that wraps all keychain operations into simple reusable functions. All the story illustrations and game assets needed optimization. I compressed all game assets like jigsaw puzzle images, coloring book pages, all activity visuals to keep file sizes small. The goal here was to keep the app lightweight because nobody downloads a 500 MB Kids app, right? Challenge fifth was offline mode and caching. Kids use apps in cars, on planes, places without internet. The app needed to work offline. The solution for this was automatic caching. So when you view a story online, everything gets saved to the device in the background. So what gets cached automatically is story text and metadata, all scene images, all audio files, reading progress, and favorites. The limitation of this was that offline only works for exactly what you have already opened online. Read a story but never played the audio won't work offline. Never opened the stories section, nothing loads. Whatever you accessed online is what works offline, nothing more. So that's the complete iOS app, the architecture, every screen explained, and the major technical challenges that I faced working on this app. So if you're following this series, make sure you subscribe so you don't miss the next videos. And if you have any questions about anything in this video, make sure to drop them in the comment section below. And see you guys in the next one. Until then, bye bye.